All right, class. Here we're going to do question 3 from this test, which is going to review using the closed interval method. So we'll get to solve some trig equations because of the nature of this question. So reminder, how does the closed interval method work? We find all the places where the derivative of our function is 0, and then we evaluate the function at each of those places as well as at the endpoints. So I want to point out those places where the derivative is 0, namely there's 1 and here's 1. So I'm expecting 2, and I can see they're both between pi and 2 pi. And so I'm going to be looking for those points when I go ahead and do this. So we'll take the derivative, which will be 1 minus 2 times minus sine of x, which is 1 plus 2 sine of x. Okay, so I want to figure out when that's 0. So that means I'm trying to solve the equation. Sine of x is minus 1/2. And that happens, again, if you're not sure, pull out your unit circle, like I should have done in an earlier video when I came across this. Sine is the x-coordinate, remember, so I'm looking at the x-coordinate being minus 1/2. Sorry, sine is the y-coordinate being minus 1/2, so I'm looking for where the y-coordinate is minus 1/2. So it is there and there, which my handy unit circle tells me is at 7 pi over 6 and 11 pi over 6. Okay. Note, we happen to have been lucky and been asked exactly for the interval 0 to 2 pi, which exactly corresponds to the unit circle. So I don't have to do any figuring out what would have happened outside by adding 2 pi or subtracting 2 pi or whatever else. Okay, so then the closed interval method tells us I'm supposed to evaluate this function at these 4 points. 7 pi over 6 f of 11 pi over 6 and f of 2 pi. Okay, so here's where it's very helpful that we have been given the graph, because if we look at the graph, we actually know which of these are going to correspond to the maximum and the minimum. Namely, this one here is going to correspond to the minimum value. And we can go ahead and calculate that minimum value. Namely, it's going to be what I plug in 0. And remember, I'm plugging it into the original function. So that's going to be 0 minus 2 times the cosine of 0, which is just minus 2, because cosine of 0 is 1. Okay, so this is our min value. Okay, then here are our 2 critical numbers. That is our 2 spots where the derivative was actually 0. And so let's look at those. Namely, we've got, this one must be 7 pi over 6 because it's a little more than pi, and then this one must be 11 pi over 6 because it's a little less than 2 pi. And the one that's actually going to be the maximum value out of these 3 points, the endpoint and those 2 critical numbers, is actually this one, which we agreed was going to be 7 pi over 6. So in fact, this one, this is going to be the max value. And we can go ahead and plug in 7 pi over 6. So this will be 7 pi over 6 minus twice the cosine of 7 pi over 6, okay, which is going to be equal to 7 pi over 6 minus twice the cosine of 7 pi over 6, which is 7 pi over 6 minus 2 times minus root 3 over 2. And so that's actually plus square root of 3. So this is 7 pi over 6 plus the square root of 3. And that is my max value. Okay. Now notice, sorry, that got slightly off the camera. Notice I don't even really have to evaluate these two. Since I have the graph, I know these both have values that are between the thing that's actually the maximum value and the thing that's actually the minimum value. So that is good enough for us. Until next time.